Automated testing using pyATS and Genie. In this lab, you will explore the fundamentals pyATS and Genie. The pyATS tool is an end-to-end testing ecosystem specializing in data-driven and reusable testing, and engineered to be suitable for agile, rapid development iterations. Extensible by design, pyATS enables developers to start with small, simple, and linear test cases and scale towards large, complex, and asynchronous test suites. Genie extends and builds on pyATS to be used in a networking environment. Examples of features Genie provides include device connectivity, parsers, and APIs. Platform agnostic, Python object models for features such as OSPF and BGP. Pool of reusable test cases, YAML driven test runner engine. Required resources, one PC with operating system of your choice, VirtualBox or VMware, DevNet Associate virtual machine, CSR1 KB virtual machine. Please review the previous labs to set up, install, and configure the images for DevNet Associate virtual machine and CSR1000B virtual machine. Look at the playlist in the video's description. Launch the DevNet Associate virtual machine. If you have not already completed the lab, install the virtual machine lab environment. Do so now. If you have already completed that lab, launch the DevNet virtual machine now. Okay, I will do it on GNS3 because for this lab and another labs, I'm using the GNS3 method. So I will use GNS3 to launch the DevNet Associate virtual machine. Cancel. Okay, GNS3 is ready, and go to File and create a new blank project. Okay, and go to End Devices section and drag the DevNet Associate virtual machine. And before to start the virtual machine, go to Oracle VM VirtualBox and right-click on the virtual machine, the DevNet Associate virtual machine, settings, and network, change NAT to generic driver or not attached. Okay, I will use generic driver and be sure the cable is connected. Okay. And start the virtual machine. Right click and start. Okay, virtual machine is ready. Create a Python virtual environment. You will create a Python virtual environment called a Python virtual environment or VM. Open a terminal and the virtual machine, double click terminal. Okay, this terminal. Creating Python virtual environment, VM. The PyATS tool is best installed for individual work within a virtual environment. A virtual environment is copied from your Python-based environment, but kept separate from it. This enables you to avoid installing software that may permanently change the overall state of your computer. The virtual environment was covered in detail in the lab Explore Python development tools earlier in the course. Create a pyATS directory and change to that directory. Okay, first create the directory pyATS in labs DevNet source directory, and then navigate to that directory using change directory tool and navigate to that directory. Okay, and make directory labs, press tab to complete. On dev, press tab to complete DevNet source and create the directory pyATS. Remember, I am on home directory, so that's why I need to specify the directories labs and DevNet source. Enter and verify. You can verify doing this. And verify the contents of the labs DevNet source directory. This is the new directory pyATS. And navigate to this. Use cd change directory and navigate to labs DevNet source pyATS. And now I am on this new directory pyATS. Create a new Python virtual environment that creates the directory csr1kb in the pyATS directory. Okay, create the environment. Python3, the virtual environment, and this will be csr1kb. csr1kb, very nice. Enter. So you can verify ls to list the contents. Now you will have this subdirectory created by the virtual environment. Review your Python virtual environment. Change directories to your new target directory csr1kb and list the files. Virtual environment creates a self-contained directory tree test project that contains a Python installation for a particular version of Python, plus a number of additional packages. It also creates a bin subdirectory containing a copy of the Python binary. notice in particular the bin subdirectory and the Py virtual environment configuration files that were created. Okay, and review the contents of the CSR1KB and long list. Okay, change directory, go to CSR, press tab to complete CSR1KB, enter, and long list. Now you can see the binary configuration file. Okay, libraries, include and share. Examine the contents of the configuration file. Notice that this file points to the location of your Python installation in USR bin. Okay, review. You can use less to review this configuration file. Enter. Now the home is USR bin directory version Q to exit and a symbolic link, also known as symlink, is a special type of file that serves as a reference to another file or directory. To get a better understanding of the B environment and how it uses symbolic links, list Python files in the USR bin directory referenced in the configuration file. Use the ls number 1 option to list the files, each on one line. Okay, list option 1, this directory user bin and all the files that starts with the Python keyword. Okay, ls option 1, the root USR bin Python. Okay, remember this is the root. This directory is not placed in my home directory. This is placed on the root, and list the files that starts with the Python keyword. And now you can see these files. Now examine the contents of the virtual environment created bin subdirectory. Notice there are two files in this subdirectory, both of which are symlinks. In this case, it is a link to the Python binaries in USR bin. Symlinks are used to link libraries and make sure files that have consistent access to these files without having to move or create a copy of the original file. There is also a file activate that will be discussed next. Okay, and in the CSR1KB subdirectory, long list the bin subdirectory. Okay, remember on CSR1KB there is a subdirectory bin. Long list to this. I am on CSR1KB and long list to bin. Enter. And now you can see this symlink or symbolic link that points to USR bin Python 3. And is this. And this another symbolic link is pointing to Python 3. And is this the same? And an activate file. Launch the virtual environment using being activate. Notice your prompt is now preceded with CSR1KB. All the commands down from this point on are within this virtual environment. Okay, source being activate. Okay, this is to launch the virtual environment. Okay, source being activate. The deactivate command is used to exit the virtual environment and return to the normal shell environment. Okay, source in Bing subdirectory there is a file activate. Okay, in Bing activate, Bing activate, enter. Okay, be careful, Bing activate. Very nice. Look at this. CSR1KB. Use the PyATS testing library. Installing PyATS. Install PyATS using pip3. This will take a few minutes. During installation, you may see some errors. This can usually be ignored as long as PyATS can be verified as shown in the next step. Okay, pip3 install PyATS full. pip3 install PyATS full. Okay. And obviously I don't have internet connection. Retry. Obviously I don't have internet connection because my virtual machine on GNS3 is not connected to internet. And do the following and close the terminal. Shut down the virtual machine and only this is better for GNS3. Stop the virtual machine. Okay, now is stopped. Now you can see the red square here. The red square for the DevNet Associate virtual machine is stopped. Go to Oracle VM VirtualBox. Change networking. Go to settings. Network, NAT. Be sure cable connected. NAT, cable connected. Okay. Start the virtual machine on VirtualBox. Okay. Not on GNS3, on VirtualBox. Okay, go to terminal. Okay, remember the DevNet Associate virtual machine is not working on GNS3 because you can see this red square. It's only working on VirtualBox. So I can connect to internet and go to the directory, go to the following directory, change directory, labs tab, press tab to complete the new directory pyATS. Tab to complete and go to CSR subdirectory created by the virtual environment CSR. Tab to complete. Enter. Once you are CSR1KB, remember to launch the virtual environment. Source bin subdirectory, activate file, enter. Look at this, the virtual environment CSR1KB, and install using pip3 install pyATS full, enter. Okay, very nice. And verify pyATS. Verify that pyATS was successfully installed using the pyATS Help command. Notice that you can get additional help on any pyATS command with the pyATS Help command. pyATS Help. Okay, very good. Clean, create, develop, and other commands. For example, create. You can do pyATS create help, enter. Okay. pyATS creates a script and library components automatically based on your input. Clone and examine the pyATS sample scripts for GitHub. Clone the GitHub pyATS sample scripts repository, Cisco test automation. And use Git Clone, and this is the link. You can review this link using web. Okay, for example, go to Chromium browser on the virtual machine. Go to github.com Cisco test automation examples. And look at this. Okay, and this is the link. So you can clone this. Remember, you are on CSR1KB virtual environment and use Git Clone. and use the link HTTPS, enter. Very nice, 100% done. Verify the copy was successfully by listing the files in the current directory. Notice there is a new subdirectory example. Okay, long list. This examples subdirectory was created. Is this okay? List the files in the examples subdirectory. Notice there is a subdirectory basic along with several other files. Okay, long list of examples. Enter. Look at the contents, the basic directories, file, directories, file, directories. List the files in the basic subdirectory. This is the location of the scripts you will be using in the next step. Okay, list the contents of basic. Enter. Okay, the scripts. Python scripts. And this is a directory. Okay, D for directory. Examine the basic script files. The test declaration syntax for PyATS is based on popular Python unit testing frameworks like pyTest. It supports basic testing statements such as an assertion that a variable has a given value, and along with explicitly providing results by specific APIs. The Python script you will use is basic example script. Display the content of the Python script using the cat command. Notice that this script contains the following section as highlighted in the output below. A common setup block, multiple testing blocks, a common cleanup block. These blocks contain statements that prepare and/or determine readiness of the test topology, a process that can include problem injection, perform test, and then return the topology to known state. The testing blocks, often referred to in pyATS documentation as the test cases, can each contain multiple tests with their own setup and cleanup code. Best practice suggests thought that the common cleanup section at the end be designed for IDM potency, meaning it should check and restore all changes made by setup and test, and restore the topology to its original, desired state. Although it is not necessary to understand the code, you will find it helpful to read the comments within the Python script. Okay, and in examples and basic directory, basic example script. Okay, this file script. Okay, you can use less, a very useful tool in examples basic. and basic press tab and script press tab. Okay, review this file. Enter. And now you can see the contents. Common setup section, test section, and cleanup section. Queue to quit. Remember, it's a Python file. A pyATS script is a Python file where pyATS tests are declared. It can be run directly as a standalone Python script, like generating output only to your terminal window. One or more pyATS scripts can be compiled into a job and run together as a batch through the pyATS EasyPy module. EasyPy enables parallel execution of multiple scripts, collects logs in one place, and provides a central point from which to inject changes to the topology under test. Display your pyATS job file, pyATS sample job. And now review this another file, the job. It's the same, but only change a script job. Enter. Import operating system from pyATS, the EasyPy module. Okay, very good. And Q to exit. Run pyATS manually to invoke the basic test case. Using the pyATS job and script files, run pyATS manually to invoke the basic test case. This will verify the pyATS job and script files work properly. The information in the output is beyond the scope of this lab. However, you will notice that the job and script passed all required tasks. The output below was truncated. The Cisco test automation repository on GitHub is subject to change, which includes the pyATS job and script files. Your output is subject to change, but should not affect your outcome. For example, an intentional failure was added to the basic example script file. This is an intentional failure and does not cause any problems. It is an example that repositories are dynamic. It is one of the highlighted lines below. There is an intentional failed. Okay, passed 3, failed 1, total 4. Okay, passed, failed, passed. Okay, and do it. Okay, in CSR1KB directory, remember you are on CSR1KB virtual environment. Use pyATS and run the job and this job. Enter. Okay, review. Error intentional failure, failed, and passed, passed, failed. Starting common setup on test case. Now clean up, passed 3, failed 1, total 4. Success rate 75%. Use Genie to parse iOS command output. You will use Genie to take on a structured iOS output and parse into JSON output. Not all iOS commands are supported. Create a testbed YAML file. The PyATS and Genie tools use a YAML file to know which devices to connect to and what the proper credentials are. This file is known as a testbed file. Genie includes built-in functionality to build the testbed file for you. Enter the command Genie Help to see all the available commands. For additional help of any command, use the command parameter. Notice that testbed is one of the options for the create command. Okay, Genie Help. Okay, and you have the options, create, develop, and other. You can do the following, and you can review the create command, this create command, Genie create help, enter. And you can see the sub commands testbed. Create a testbed file automatically. To create your testbed YAML file, enter the command below. The output parameter will create a testbed file in a directory named YAML. The directory will be automatically created. The encode password parameter will encode the passwords in the YAML file. The parameter interactive means you will be asked a series of questions. Answer no to the first 3 questions, and then provide the following answer to create the testbed file. Okay, you will set the device hostname, CSR1KB, case sensitive, the IP address. Remember, on all labs, the IP address of the router is 192.168.56.101, the IPv4 address. The username, Cisco, on all labs. The default password, Cisco123 and exclamation mark for all labs. The enable password, blank. There is no privileged password configured on the router. The protocol SSH. Operating system, the operating system of the router. Okay, and create Genie create testbed. Interactive for the to ask questions. Okay, and the output will be placed on a testbed file placed on YAML directory. then encode passwords. Okay, do it now. ls. So the YAML directory is not created, but the Genie will create this directory. Genie create testbed interactive output YAML directory and testbed point YML space dash dash encode dash dash password. Okay, only one dash, only one. Review. Genie create testbed interactive, the output on YAML, the file testbed point AML dash dash encode dash password. Enter. Okay, and answer no to the first 3 questions. Okay. Do all of the devices have the same user? No. Do all of the devices have the same default password? No. Do all the devices have the same enabled password? No. Hostname. Be careful. Set CSR1 KB sensitive. CSR1 KB. Enter. IP. Remember 191.68.56.101. Be careful. Enter. Username Cisco. Password Cisco123 exclamation character. Okay, you will not see the output and because it's hidden, so be careful. Enable password. Leave blank. Okay, only enter. For protocol, do this. SSH and the key exchange group expected by the router, and use this. SSH, the key exchange is KEX algorithms Diffie Hellman group 14 SHA1. Okay, Diffie Hellman group 14 SHA1. Enter. Very nice. The operating system of the router, iOS XE. More devices to add? No. Testbed file generated. Okay, and review ls. You have the YAML directory and on this directory there is the testbed file. And view the testbed file in the YAML directory. Notice your entries in the YAML file. Your SSH password is encrypted, and the enabled password will ask the user to enter password if one is required. Okay, verify. Useless the test tab to complete, enter. And look at this, the device CSR1KB, the connections, command line interface, the IP4 address 56.101, the protocol SSH with the key exchange, Diffie-Hellman group 14, SHA1, the credentials, the password, encrypted password, username Cisco, enable password, and the enabled password will ask the user to enter the password if one is required. Okay, it's blank for now, and operating system and type Q to quit. Use Genie to parse output from the show IP interface brief command into JSON. If you have not already completed the lab install CSR1KB virtual machine, do so now. You have already completed that lab, launch the CSR1KB virtual machine now. And go to GNS3 and add the router CSR1000B. Okay, and connect the router gigabit 1 to the virtual machine Ethernet 0. And show high interface labels. Okay, very good. But remember, the DevNet virtual machine for now is not running on GNS3, it's running on VirtualBox. So close this. And shut down the virtual machine menu, quit, shut down. Okay, go to settings, networking, change NAT to generic driver, and be sure cable is connected. Okay. And start the virtual machine on GNS3. Start. Okay, go to terminal. And access to the subdirectory CSR1KB, cd labs, DevNet, press tab to complete, pyATS and CSR tab to complete, enter. Once you are on the CSR1KB directory, start Or launch the virtual environment. So the source is being activate. Activate. Be careful. Enter. Now you are in the virtual environment, and verify on YAML directory you have the testbed file. Okay, and you can see the contents. Test. Very nice. Thank you. And now start the router. Start. Double click and wait. May take a while, as you can see in the previous labs. Would you like to enter the initial configuration dialog? No. Would you like to terminate auto install? Yes. Wait a moment. Okay, enter. This is the user exec mode. Okay, wait a moment. Enter user exec mode. The prompt. As you can see in previous labs, you need to configure this router. So first, enable configure terminal. Set a host name. You can use CSR 1KB. C uppercase, S uppercase, R uppercase, 1, K, lowercase b, lowercase, enter. Configure the interface gigabit 1. Remember, I'm using gigabit interface here. Enter. And set the IP address. Okay, and all apps, the IP address of the router is 192.168.56.101. 192.168.56.101, and this subnet mask not shut down to enable the interface. The interface is up, enter, exit. And now the router is connected to the virtual machine, and on the virtual machine open another terminal window, an IP address to verify. This is the Ethernet interface, EMP0S3, no IP address. So on the router, create a DHCP server to list an IP address for the virtual machine. IP DHCP excluded address, exclude the IP address of the router, also the server. Create a pool. For example, DevNet name, use any name, network 192.168.56.0 with this subnet mask, and that is enough. Exit. And go to the virtual machine and review again the IP address. And again. Again. Okay, IP address. Okay, and finally EMP0S3 192.168.56.1. Okay, ping to the router, pings to 192.168.56.101. Success, Control C to stop. And okay, also configure SSH. So remember, you will use the SSH protocol to connect the router. Okay, and first set domain, IP domain name cisco.com. Use any domain and create a username Cisco with privilege 15, the maximum privilege for privilege exec mode. The secret password Cisco 123 exclamation mark. User Cisco privilege 15 Cisco 123 exclamation mark. Username Cisco and password Cisco 123 exclamation mark. Enter. Okay, okay, and generate the crypto key. Crypto key generate RSA general keys modulus 1024. Okay, ready. Enter. Configure the virtual terminal lines IBTY 0 to 15 transport input SSH to use SSH protocol transport and login local to use this local username and password. That is enough. No enable secret password. Okay. Enable password none. Okay. And test. I'll go to the virtual machine here. And SSH, the user is Cisco, the IP address 56.101. If you got this message, warning, remote host identification has changed, remove this file in this directory. Okay, rm home dev associate hidden directory that point ssh and known tab. Okay, remove this file. Be careful. Remove this file. Enter. And try again. SSH Cisco is the user. The IP address. Yes. Password Cisco 123 exclamation mark. And very nice. It's working. I am in the router exit. And in the CSR 1KB virtual machine, enter the command show IP interface brief from privilege exec mode. Your address may vary, don't worry, but anyway, make note of the IPv4 address for your CSR 1KB virtual machine because you will use it later in this lab. Okay, on the router, show IP interface brief. here. Enter an exit on privilege exec mode here. Privilege exec mode. Enter show IP interface brief. Okay, and verify on gigabit 1 the IP address 192.168.56.101. The address of the router. Using your testbed YAML file, invoke Genie to parse unstructured output from the show IP interface brief command into a structured JSON. This command includes the iOS command to be parsed show IP interface brief, the YAML testbed file, and the specified device in the testbed file CSR 1KB. Okay, remember you are in the environment and you are on this CSR 1KB directory. Okay, you should be on the in the environment and CSR 1KB directory, and use this Genie parse show IP interface brief, and this is the command, but the testbed file is the existing file created previously, and the device is CSR 1KB. Okay, Genie parse quotation marks show IP interface brief testbed file. Sorry, testbed file. The file is placed on YAML subdirectory, and the file is testbed.yml space and the devices CSR 1KB. Enter. Using the default YAML encoding key, since no key was specified in configuration, this is a shared key and is not secure. I got this message because on router I created a crypto key. I generated a crypto key, but it's a general key. But on the configuration of the testbed, configuration, the crypto key is Diffie-Hellman group 14 SHA1. Okay, and they are different. And there is a question, this enter enable password for device. No enable password, remember, no enable password. No enable password. Enter. Okay, and I got this device CSR 1KB connection command line interface does not have an IP or port specified, ignoring. Okay, don't worry about this message. And 100%. Okay, this is the JSON output. Remember the show IP interface brief on the command line interface on the router, gigabit 1 IP address, yes method, manual, status app, protocol app, and other interfaces from 2 to 4 on assigned IP. Okay, yes, method on set, status administratively down, and protocol down. Should be something similar. Gigabit 1, okay, interface, okay, yes, IP, method manual, protocol out, status up, and other interfaces, yes, on assigned, on set, down, administratively down. Okay, that is very good. Use Genie to parse output from the show version command into JSON. Okay, the same command, but instead of show IP interface brief, use show version. Okay. Repeat and change the command, the iOS command show version. Enter. Enable password none, enter. Okay, very good. The version. But to compare, go to GNS3, the command line interface, show version, space, and on show version command you will see. Okay, and show version, you can see the Cisco iOS XE software version 16.08, the iOS ID image, and version 16.8, and also interfaces, processor board. Okay, the NVRAM, the physical memory, and virtual hard disk, and compare. Virtual hard disk, the hostname, image ID, the operating system iOS XE, 4 gigabit interfaces, 16.08, very nice. Use Genie to compare configurations. As you have seen, Genie can use it to parse show commands into structured JSON. Genie can also be used to take snapshots of configs annually and make comparisons between them, automate testing deployments against a virtual environment for testing before deployment in production, to troubleshoot configurations by doing comparisons between devices, add an IPv6 address to the router. Okay, add this IP. We do this on GNS3 on the privilege exec mode, configure terminal. And this is global configuration mode, config, interface gigabit 1, IPv6 address 2001, DB8, ACAD, 56, column 1 of 1, prefix 64. Okay, be careful with the IPv6 address. And that is enough, exit. Use Genie to verify configuration and parse output in JSON. Okay, parse unstructured output from the show IPv6 interface command into structured JSON. Use the output parameter to send the output to a directory verify IPv6 1. Notice in the output that Genie tells you that 2 files were created. Okay, it's the same command, the same line, but change show IPv6 interface gigabit 1. Show IPv6 interface gigabit 1. Use the same test bed, the same device, with the output on this directory. Okay, this directory will be created automatically. So repeat the previous command, change show version by show IPv6 interface gigabit 1. Okay. The testbed file, the same. The device is the same, but add the following output space this directory verify dash IPv6 dash 1. Enter. Okay, and enable password, enter none. And look at this. Genie parse summary for CSR1KB connected, and the log is I just created a file connection CSR1KB txt, and parse command show IPv6 interface gigabit 1. And the first file is this show IPv6 interface gigabit 1 parsed and console, both txt files. You can verify this ls, and look at this directory was created, and you can verify also that verify IPv6 1. You should have 3 files, this 1, 2, and 3 files. List the files created by Genie in the directory verify IPv6 1. Notice there were 2 files created with the similar names, with one ending in console and the other in parsed. The name of each file includes the device name and the iOS command used in the Genie parse command. You can verify with long list. Okay, long list. Okay, very nice. Examine the contents of the console file. Notice both the IPv6 global unicast address that you configured and an automatic EUI 64 link local address. Okay, and just useless. The directory verify IPv6.1, the file CSR, press tab to complete, and console tab to complete. Okay, this is the file, enter. Look at the contents of the output. Interface 1, gigabit protocol app, interface app, IPv6 enable, link local address, no virtual local link, global unicast, the previously configured IP address, IPv6 address, and joined group addresses. And this is the automatic EUI 64 link local address. Q to exit or quit. Examine the contents of the parsed file. This is the parsed JSON file of the show IPv6 interface gigabit1 command. The same but changed to parsed. Repeat but changed to parsed. Parse. Enter. Okay, the JSON output, the interface IPv6, prefix 64, the link local address. Very good. And the DevNet group addresses. Q to quit. Modify the IPv6 link local address. And interface gigabit 1 IPv6 address. Use this. Okay. Set manually. Okay. I am on global configuration mode. Interface gigabit 1 IPv6 address. Use this FEA0 colon 56 colon 1 link dash local. Very nice. Enter. Exit. Use Genie to verify configuration and parse output in JSON. Parse unstructured output from the show IPv6 interface command into a structured JSON. Use the output parameter to send the output to a different directory. Verify IPv6 too. You can use the command history to recall the previous command, up arrow. Just make sure you change the one to 2 to create a new verify IPv6 directory. Okay, be careful. Basically, it's the same command. Show IPv6 interface gigabit 1, the same testbed, the same device, but the output goes to a different directory. Be careful, be careful. The virtual machine. Up arrow to find the previous command. Genie parse show IPv6 interface gigabit 1, same testbed, same device. Output verify IPv6 2. Okay, enter. Okay, be careful, is 2. And press enter here. Very nice. On this directory, verify IPv6 2, there are 3 files, 1, 2, and 3. Okay. List the files in the new subdirectory, verify IPv6 2, long list, ls long list verify IPv6 2, enter. Okay, there are 3 files, the connection, console, and parsed. Examine the contents of each file. Okay, verify the console and parse. Okay, use last verify IPv6 2. Verify the console. Okay, this is the console output. Okay, this is the output just like the command line interface on the router iOS. Q to quit. Change this to parse. Okay, remember on the subdirectory number 2, verify IPv6 2. Parse, enter. The JSON output Q. and use Genie to compare the difference between the configurations. In the previous step, it is fairly easy to find the change to the IPv6 link local address. But assume you are looking for a problem in a complex configuration. Perhaps you are trying to find a difference between an OSPF configuration on a router that is receiving the proper routers and another router that is not. And you want to see the differences on their OSPF configurations. Or perhaps you are trying to spot the difference in a long list of access list statements between two routers that are supposed to have identical security policies. Genie can do the comparison for you and make it easy to find the differences. Use the following command to have Genie find the differences between the two parse JSON files. Notice that the output tells you where you can find the Genie's comparisons. In this case, the first file name is the previous configuration, and the second file name is the current configuration. Okay, use Genie diff. Okay, for difference, Genie diff. The first subdirectory verify IPv6.1 and the new verify IPv6.2. Okay, it's very easy. Genie diff verify IPv6.1 and verify IPv6.2. Enter. Genie diff summary between directories. Okay, for example, this file, the parsed file, difference can be found at a new file created, difference CSR1, show IPv6 interface. View the contents of the file with the differences. The plus sign indicated additions and the minus sign indicates what was removed. Okay, and view the file. Remember, this file is placed in the current directory, so use less to view this file. Diff, press tab to complete, and enter. Okay, and the automatic link local address was removed, and the manually link local address was added. As you can see, a difference in the group addresses. Q to quit. Lab cleanup and further investigation. You will deactivate your Python virtual environment and investigate other Genie use cases. Deactivate your Python virtual environment. When you have completed this lab, you can deactivate your Python virtual environment using the deactivate command. Notice that your prompt is not longer preceded by CSR1KB. Just deactivate. Deactivate. Now, this is not present anymore. CSR1KB is not present anymore. Explore more PyATS and Genie use cases. You cloned examples folder from the Cisco test automation with PyATS and Genie repository on GitHub. There are many other use cases in this GitHub repository. You may wish to explore other folders and various other use cases. See the following websites for more information. Okay, go to the virtual machine and list the contents of this directory. You have the examples directory from GitHub. You can see the contents examples. For example, go to clean. Alex examples clean is a subdirectory. And you can find, for example, this full clean for CSR 1000B iOS XE. It's another subdirectory review. Full tab clean CSR tab and enter to list and review this file clean YAML and testbed YAML. Okay, clean tab and review with less, enter. Okay, the devices, the images, device recovery, being the server copied to Linux, copy to a device, apply configurations, okay, and verify, queue, and also review the testbed YAML, enter. The address, SCP, the devices, okay, queue. So you can use the YAML file and the testbed. Also, you can review basic on examples, basic, enter. The job and the script. Also, you can go to Genie and help. You can see you use it create to create the testbed. You use it difference to differentiate to snapshots, save it to a file or directory. We use it parse show commands. But also you can use learn to learn device features and save to a file, or run Genie triggers and verifications in PyATS runtime environment. So I can use learn. Okay, for example, the previous command with go to the environment, activate the environment, source being activated. Okay, on this directory CSR1KB. Okay, this is the environment CSR1KB, and use learn. Use the Genie line and Genie. Okay, and use learn. Genie learn use the test bed I just created specifically for my router. Okay, test bed to connect the router. Genie learn devices CSR1 KB, and but you need to specify what to learn. You will learn dynamic routing, or learn interfaces, or learn SSH configuration, or any other. You can learn interface, for example. Use the testbed, the same testbed that I used previously. The devices is the same CSR1 KB, and you can set an output, a directory to store the data. Okay, for example, learn dash int dash 1 and enter. Enter. Okay, connected. Learn feature interface. Look at this. Okay, 3 files created, the log, and in the learn int1 directory, 2 files, OPS and console, and review those files. Useless, learn tab, and interf tab, OPS tab. Okay, and verify the contents of this file. You can see the JSON output. Gigabit 1. Okay, Q and console. Okay, for example, show interfaces, Gigabit 1, IP addresses, Gigabit 2, Gigabit 3, Gigabit 4. Okay, very nice. A lot of information. Q to quit. Or also you can learn about all features. All. Okay, but be sure to place in another directory. But I will try SSH. Learn about SSH on my router. Use the same testbed, the same devices, and another directory called learn SSH1. Enter. Enter. Okay, a feature not yet developed for this operating system. Okay, it's an exception. Okay, look at the exception on learn SSH1, SSH tab, the exception.txt, enter. Okay, could not find a feature called SSH. Q to quit. But anyway, you can learn and use more options. When you finish deactivate. Okay, look at this, no environment, deactivate, and close the terminal. The another terminal on GNS3, you can stop the virtual machine and close the command line interface on the router, and you can stop the router. Okay, and finally close GNS3. And go to VirtualBox, go to DevNet Associate Virtual Machine, Settings, Network, change to NAT, and Advanced Cable Connected. Okay. Thank you very much.